why it can be predicted. Okay, why it can be predicted, how it can be predicted. Which series can be predicted that what will happen tomorrow? Can I predict this thing that what will happen tomorrow? Can I predict here? Is it possible to predict here? Is it possible to predict here? Anybody, please tell me.
In the first picture, but in the first one, we can predict. But in the second and third one, we cannot predict.
But in the
second and third figure.
Okay, how many of you say that we can only predict A? How many of you say we can predict A and B? And how many of you can say that we can predict all of them?
Sir, I think none of them. Yes, sir.
None of them. You cannot predict none of them?
No.
We can predict all.
We can predict all.
You can predict.
We can predict all.
Yes, you can predict all. The answer is correct. You can predict all. Now the question is, why you can predict all? What is so?
There is a trend, sir.
There is a trend. Okay.
Trend and pattern.
Trend and pattern is there. So there is a definite trend and there is a definite pattern because of which you are able to predict. Right. Now see something another. Can you predict this thing?
No, sir.
Why we cannot predict? Now pattern is not there. But I want some very technical answer. Why you can? Because you have heard the econometrics quite number of times.
It is irregular.
Not stationary.
It's not stationary.
It's not stationary. So the word has emerged which I was looking for. Okay. The word has emerged, it is not stationary. Who has said this word is not stationary? It's not stationary. Okay. Keep that word reserved right now, stationary. But what is missing in this and because of which we are not able to predict? Tell me.
It is not oscillating to the average mean. Constant mean.
Constant mean and
constant
variance.
Right. So let's try to understand the constant mean and constant variance concept. If I dissect this series into two parts, and if I say A, okay, and I dissect, sorry, it's not working. What are the chances that both this mean will be equal? What are the chances? Mean, I'm just saying mean. Okay. Very high chances that the mean will be equal. Very high chances. Now, suppose if I dissect this part and I dissect this part, will the mean remain constant? Is the mean constant? The mean has changed. First observation from this series is mean has changed. The second thing,
Sir, you are not audible, sir.
remain constant in this.
Yes, sir.
Here the covariance will not remain constant. Okay. Now, because of this reason, I am not able to predict what will happen. Is it clear? Clear. Stationarity, clear. The stationarity is a term used for the series which has got the constant mean, constant variance and constant covariance. Simple. Matter is over. Any questions now? Okay. Now I will show you something else. Okay. I am in my presentation I never used the long equations or long formulas. I try to make the things so simple so that you can understand and it is in a palatable format. I'll show you something else. Okay. And you will be able to understand that what we are trying to do. What is this thing? What is this thing? Okay. What is this thing? What is this thing? What is it?
The trend.
No. No, somebody else said this thing. What is it? First person who said this.
What?
ECG. Huh? It is a ECG. Okay. It is a ECG. Now, what is the characteristics of the ECG? What are the characteristics of the ECG?
It is oscillating between positive and negative.
Is there any other characteristics?
With some amplitude on positive as well as negative side.
It is a mean returning series.
Yes, mean reverting process.
It's a mean reverting process. It returns to the mean. How much it oscillates, it returns to the mean. Is it clear? And if this process is smooth, then probably you will be able to predict that the person may live up to next 20 or 30 years. If these things are good. Now, suppose the oscillation process is not in a good shape. Okay, the oscillation process is not in a good shape. Okay, there is some problem. What you will do? What the doctor will do? What the doctor will do?
Prescribe to make it again.
Sorry?
Prescribe medicine to make it again normal.
Right. So one is medicine. Okay, one is medicine. I will come to all this. I will connect all these dots. Don't think that I am moving haywire. Don't think that. I will connect all these dots one by one. Okay, and if the things don't get settled by medicine, what to do?
Surgery.
Sorry. Okay. Now forget the hard portion. Again come to time series. Y is equal to x square. Okay. Is this series stationary or not?
Not stationary.
Not stationary. Okay. Anybody else? Anybody else who can tell me that this is not stationary? Anybody?
We can log it.
No, not.
After taking log, it's stationary.
Yeah, I'm coming to it. But is this a linear? Is this a series linear or not? Is the linearity present in this series or not? Okay. Yeah. Is it linear or not?
It is exponential.
It is exponential.
Right. It is exponential. But can I say it's a linear or not?
Yes, sir, you can say.
Yes, sir. The value of x is squared always. If it's 3 means 3.
Yeah. It is a linear series.
Yes.
Don't get confused. This is given in Damodar Gujarati. Okay. I hope you must be reading Damodar Gujarati. This is the linear series. Then what is non-linear series? The non-linear series consists of this type of arrangement. Y is equal to c square and x square. Then only it is non-linear. Now how this is linear? Okay. So first thing which I can do is I can give medicine. And what is a medicine? If I apply log on both the sides, those who are coming from engineering or science background, they know it, that this will become 2 log x. Okay, this will become 2 log x, and now your series is stationary. So this is the medicine which has been given to make the series stationary. Medicine. Okay. Still, if it is not getting stationary, then what we do, we take the first differentiation of it, and that is dy by dx, and that gives me, what is dy by dx? Anybody from math science background? Dy by dx? Anybody from science background? What will be dy by dx?
First differentiation.
It will be 2x, right? It will be 2x, and this is the surgery on the data. Okay, when you differentiate for one time, the series is known as integrated of the level 1. If you differentiate for second time, it is known as, if you differentiate for the second time, it is known as I2. Is it clear? Now my question to all of you is that if I differentiate for n number of times, then it will be known as what? If I differentiate for n number of times, it will be known as what? Can anybody tell?
Tending towards infinity.
Okay. Yeah. Anybody, any other answer?
We can't differentiate after second difference.
Very nice. Who was it?
Bharadwaj, yes, sir.
Very nice. You cannot differentiate more than 2 times, or in other words, you should not do the surgery more than 2 times on any patient, because it is risky. Okay. So at the most you should go up to I2. Now the question is, why we are saying that we should not differentiate more than I2? Let's try to understand. Suppose there is one series whose numbers are 45, 47, 54, 19, 60. I want to differentiate. I want to take the first difference. So I will create one leg. 45, 47, 54, 19, 16. Now the first difference. So what will be the first difference? Equal to. Now we have lost some information. As we are not having anything here, we cannot take this thing, and as nothing is here, we cannot take this. So by doing first differentiation, 2 observations are lost. Right. When we will take the third, again 2 will be lost. So 6 observations are lost. Suppose your data is of 15 years, annual, and you take 2 differentiation, 4 observations are lost. So you are sacrificing the data for every differentiation you conduct, and therefore it is all in first, that is take the log first, and then only you should proceed ahead. for taking for doing any other surgery. Any doubts? If you are having, please ask. Now, any doubts? No? So I'll start the regression analysis, and from regression analysis I will change the path in between, and then I will switch to Arima models, right? Arima models. Why I am taking the path of regression analysis? Because Arima has got the base in regression analysis, and that's the reason I'm giving the explanation for Arima, right? For regression analysis. Now we want to make an equation that is y is equal to a plus bx1 plus cx2 plus dx3. This is a very clear-cut equation for cross-section analysis. Why this is a cross-sectional analysis? Because there is no term of y in it. Why it is not there? Let's see. Let's move on. See, this is an equation which is talking about that in any what is the relationship between population and TV sets demand in any city. So depending upon the population, I am trying to make the demand of TV sets demanded. That's a linear regression, and we want to find out. Okay, it is necessary that we should be having the y as a dependent variable and x is a independent variable. Now life is very simple when I say that y is dependent and x is independent in case of cross-sectional study. But as soon as I switch over to time series, my life becomes complicated. Why? I will come over that part, right? Okay, fine. This is an equation which we have to make. But before I try to explain this equation, a complicated equation, let's try to understand this thing by a very small, simple example. A doctor can measure your blood pressure using his spigomanometer, right? And he can, and suppose we have made some theoretical equation in which I can, without measuring by using spigomanometer, you just tell me your age, you just tell me your weight. I'm just giving you a hypothetical equation. There is no such equation, but I'm just trying to explain something. Now, what do I mean by what is the equation which is there? See, nature has not given any equation to any phenomenon. Any natural phenomena, nature has not given any equation. It is the humans who are trying to give the equation to the natural phenomena. For example, global warming. For example, the rainfall, and we are trying to give the equation to the nature so that we can predict. And why we want to predict? So that we can reduce uncertainties. We can plan something. Okay, and that's the reason we are trying to predict. Now, it is not necessary that your prediction power always has 100%. It's not necessary. And nobody has given you the permission. Suppose you get the prediction power 100%. It means that suppose whatever you say will happen, you are next to the God. And God has not given such permission to take this position. So your prediction power can be nearer to 70% or 80%. And that you are just trying to reduce the uncertainty element. Now, there are many disciplines in which we have got the success up to 100%. Yes, we have got the success up to 100%. There are many disciplines. Now, one of the disciplines which can be considered as the landmark discipline is the astronomy. Okay, astronomy. Here, just imagine that we can also tell that what will be the sunrise after 120 years or 140 years, or on in which year this meteor will pass the Earth, and at present we all saw the conjunction of Jupiter, and after how many years this conjunction will be seen again. So all these things can be predicted with 100% accuracy. I'll request all of you to please mute your mic. If it is necessary, then ask the question. I'm requesting. Okay. So here we have considerably reduced the uncertainty element. Considerably. Why? Hello. Organizers, please can you mute the mic? Whose mic is it? I request. Hello.
Yes, sir.
Hello.
Yes, sir. I've already.
Okay. Now I will definitely talk about Arima. Get assured. I'll slowly take you on that path. What I'm trying to say is just pay attention. Now we are able to reduce the uncertainty component in this because they are celestial bodies, and celestial bodies don't change the pattern. Okay. And we are trying to make an equation on human bodies or human psychology or human, all the economics and everything, it is related to humans. And therefore, in such scenario, the humans change the pattern. And as the humans change the pattern, the equation which we have made is no longer a valid equation. So what we are trying to do, we are trying to create the sample on a large, from a large population by drawing a sample, and we are trying to stabilize the equation. But believe me, the best equation can also have an error. Now, what is the error? The error is the difference between actual and the predicted blood pressure is the error. Error is always bound to be there in your statistical equation. The entire econometrics is based on this error. If you read the first chapter, if you read the book of Damodar Gujarati, the first 4 chapters have been dedicated to the error. Now, what is this error and what is its name? This is a devil. You cannot avoid the devil. There are no chances that you can avoid the devil. Now, if you cannot avoid the devil in your love story equation, which we want to make. Why I want to make this equation? To predict. So you cannot avoid the devil. So if you cannot avoid the devil, I can at least put the devil behind the bars, and I expect some kind of behavior from them. So what is the thing which I'm expecting from this devil? Let's try to understand. That devil should not increase or decrease. Okay, it means that the devil should not increase or decrease. The devil goes in the jail and then he tries to flex his muscles and he is becoming stronger. So we don't want that. So the error component should not increase or decrease. If error component is increasing or decreasing, it is known as heteroscenasticism. I will give you a very layman example to make you understand what is heteroscenasticism. When you started typing for the first time, you generated many typographic errors. But eventually, as the time passes, the typographic error reduced. When you started driving the vehicle for the first time, there were many lucky people on the road who were passed by you. But as the time passed, the error started reducing. Similarly, the second type of error is autocorrelation. The devil should not make friendship with another devil in the jail. Okay, because if he makes the devil makes friendship with another devil in the jail, the devil becomes stronger. Here, the same concept is the error should not be correlated with the previous error. If such scenario is there, then it is known as autocorrelation. The third type is independent variables. There should not be any relationship of independent variables. In love story, there is only one dependent variable, one independent variable. Clear, we don't want more independent variables. We don't want complexity, love triangle in our story, love story. Because if there is a love triangle, it is a problem of multicollinearity. Two independent variables are correlated with each other, and therefore they are creating the problem. And such problems can be, a simple example is that suppose in your equation there is a weight, and in the second variable is a BMI. Now BMI and weight are already correlated with each other, and therefore when you take them in the equation, it creates a lot of problem. Is it clear? So now one thing is very clear, you cannot avoid the devil. But why I cannot avoid the devil? There are some reasons to it. The first reason is that in our equation, we take some variables which can be measured with a very high accuracy, like age. Your age, if it is measured here or if it is measured somewhere else, at this moment of time, it will give you the same result. Your age is this only. Okay. The second type of the variable is income and consumption. Now, this income and consumption, the accuracy level is decreasing. You will be surprised at how the income and consumption can decrease the accuracy level. For example, if I am asking in my survey to someone that what is first person understood my question and he responded monthly income. Second also 4,000. Second said 7,000, 8,000. And when we went to the 10th person, he misunderstood and he misunderstood as annual income and he wrote down 10 lakh. Now when he wrote down 10 lakh, now what will happen is